Wherever P may lie, let POX be equal to theta and OP be equal to R. Clearly, X will be equal to R cos theta and Y will be equal to R sin theta. Note that the sign of X and Y corresponds to the angle and the quadrant in which it lies. Let Z equal to X plus iota Y, then X is equal to R cos theta and Y is equal to R sin theta. Z becomes R cos theta plus iota times R sin theta. Taking R common, you get R times cos theta plus iota sin theta. Clearly, X square plus Y square equal to R square. That gives you R equal to square root of X square plus Y square, which is equal to modulus of Z. And cos theta is equal to X upon R, that is X upon square root of X square plus Y square. Similarly, sin theta will be equal to Y upon R, that is Y upon square root of X square plus Y square. Here OP is equal to R, which is equal to modulus of Z and is called the modulus of Z. Theta is equal to POX, which is called the amplitude argument of Z. This is denoted by ARG, argument of Z, or amplitude of Z. Note that theta can have multiple values in the form of 2 and pi plus minus theta. But that value of theta which lies between minus pi and plus pi, covering all quadrants, is called the principal value of the argument. In order to find the principal value of a complex number, we have the following working rule. Let alpha be the acute angle which is given by tangent alpha is equal to modulus of y by x. Whatever y may be or x may be, modulus of y by x will be always positive. Therefore, we can find out an angle alpha where tangent alpha is modulus of y by x. Then, if theta lies in the first quadrant, theta will be equal to alpha. If theta lies in the second quadrant, theta will be equal to pi minus alpha. Similarly, if theta lies in the third quadrant, theta is equal to minus times pi minus alpha. And theta lies in the fourth quadrant, then theta will be equal to minus alpha. Also, if y is equal to 0, x is greater than 0, theta is given to be equal to 0. If y is equal to 0 and x is negative, less than 0, theta is taken to be pi. If x is equal to 0 and y is positive, that is y is greater than 0, then theta is equal to pi by 2. If x is equal to 0, y is less than 0, then theta is taken to be minus pi by 2. Now the properties of argument are as follows. That is, argument of minus z is equal to minus times pi minus argument of z. And argument of z bar is equal to minus times argument of z. Argument of z1 into z2, that is product, is equal to argument of z1 plus argument of z2. And argument of z1 by z2 is equal to argument of z1 minus argument of z2. Also, argument of z raised to power n is equal to n times argument of z. And argument of 1 by z is equal to minus times argument of z. To illustrate the above facts, let z equal to r cos theta plus iota sin theta. Clearly, argument of z is equal to theta. Then minus z will be represented by minus times r into cos theta plus iota sin theta, which can be written as r times minus cos theta minus iota sin theta, or r times cos of theta minus pi plus iota times sin of theta minus pi. Therefore, argument of minus z becomes theta minus pi, which can be written as minus times pi minus theta or minus times pi minus argument of z. Let z equal to r times cos theta plus iota sin theta. Therefore, argument of z is equal to theta. Z bar will be represented by p dash, which is r times cos theta minus iota sin theta, which can be written as r times cos of minus theta plus iota times sine of minus theta. Hence, argument of z bar is minus theta, that is minus times argument of z.